On March 31st, 2026, something wild happened.
It really did.
A tiny configuration mistake basically cracked open a black box. It exposed 512,000 lines of top-secret AI source code, beat. And honestly, it proved that every single developer is using the tool entirely wrong.
Completely wrong.
Welcome to the deep dive. Today, we are exploring a massive accidental leak.
Specifically, the internal TypeScript code for Claude Code.
Right. We are going to unpack its hidden architecture.
We will explore the 85 secret/commands.
We will look at exactly how to configure your permissions.
And finally, we will reveal the upcoming Kairos mode.
The things we learn are staggering.
It is a fundamental shift in how we build software. People are barely scratching the surface of this tool.
They really are. And to understand why our current AI results are stagnating, we first have to look at this exposure.
Yeah, we have to look closely at what it actually revealed.
It basically showed us the software's true DNA.
Exactly.
Yeah.
Let's start with how this actually happened.
Okay. The leak occurred through a misconfigured bundler.
Which is just a tool for packaging JavaScript, right?
Yeah, exactly. It is a highly optimized bundler used by modern development teams. When you build software, you bundle thousands of files together, but someone made a tiny configuration mistake during the build.
And that mistake created an npm source map error.
Right.
Let's break that down for people outside the JavaScript ecosystem.
Sure.
A source map is basically a translation file, isn't it?
That is a great way to describe it.
Yeah.
Since bundled code is unreadable, developers use source maps for debugging. It maps the minified code back to the original source. But this specific source map accidentally pointed directly back to Anthropic's TypeScript.
So it accidentally published the architect's highly classified blueprints.
Precisely.
Yeah.
It left the internal code completely exposed to the public.
Wow.
And what we found in that underlying code was absolutely staggering.
Where do we even start?
Well, first off, Claude Code natively supports Opus 4.6. That is the incredibly powerful new reasoning model.
Right, and it operates with a native 1 million token context window.
1 million tokens? That is massive.
Yeah.
You could basically fit an entire operating system in there.
You really could. It holds vast, interlocking code bases in its memory simultaneously. But honestly, the token limit isn't even the biggest revelation here.
Really?
Yeah. The most important takeaway from this entire leak is architectural.
How so? What are we missing?
We have been treating this thing like a simple terminal chatbot.
Right.
But the leaked code proves it isn't a chatbot at all.
What is it then?
It is a highly optimized agent runtime.
An agent runtime. Let's unpack what that actually means mechanically.
A chatbot is mechanically simple. It waits for your text prompt, and it replies with text. An agent runtime is an active, continuous operating environment. The leak revealed a sophisticated 3-layer memory system built right in.
3 distinct layers. What is each layer doing exactly?
Well, it maintains a highly focused working memory for your immediate tasks.
Okay.
It has an episodic memory tracking your current session history.
Right.
And it builds a deep semantic memory mapping your entire code base.
So it actually remembers how your specific project fits together.
Exactly.
It isn't just starting fresh every single prompt.
Not at all. It also features a native CLI parser. It understands complex terminal commands natively, and it utilizes continuous tool execution loops.
So it can run a command and read the output.
Right. Then it dynamically decides what to do next without asking you.
Treating this like a chatbot feels entirely backwards now.
Yeah, it really does.
It is like walking into a professional wood shop, staring at a table saw, and just yelling, "Make me a chair."
Exactly.
You're doing it without measuring anything.
That is the perfect analogy.
Yeah.
You are completely ignoring the actual machinery.
Right.
A chatbot just waits passively for your text prompt. But this runtime is designed to work autonomously. It plans its own complex steps. It actively controls its own context window.
Wow.
It divides massive, overwhelming tasks into smaller, manageable parts.
So why does the old chat mindset fail so completely here?
Because the chat mindset is fundamentally reactive and incredibly imprecise.
Right.
You write a long, vague text prompt, you just cross your fingers and hope the AI guesses correctly.
Yeah.
But an agent runtime expects to actively orchestrate complex workflows. If you just chat with it, you bypass its entire coordination system. You leave its most powerful orchestration tools sitting unused.
So chat relies on guessing, while agents orchestrate actual structured workflows.
Precisely. You have to actively engage the underlying orchestration engine.
Right. So if we shouldn't just chat with it...
How do we actually command it?
Exactly. I assume that is where the hidden architecture comes into play.
You assumed correctly. The npm leak exposed over 85 hidden slash commands.
85. That is a massive toolkit.
It really is, and most users don't even know they exist. A typical user might occasionally use /help, or maybe they type /context. But power users are relying on a completely different set of tools.
Let's talk about some of those hidden tools like /init.
Yeah, /init is crucial for starting a new session.
Okay.
It instantly scans and sets up your project context. It builds that semantic map we just talked about.
What about token management? You mentioned the million token window.
Right.
That gets incredibly expensive fast.
It absolutely does. That is where /compact comes in.
How does that work?
It is a brilliant little command. It basically compresses your unnecessary conversation history.
Oh, nice.
It reduces bloated context while keeping the core instructions intact.
So it saves you massive amounts of wasted tokens.
Exactly. And speaking of tokens, there's also /cost.
Oh, I love that one.
Yeah.
It tracks your current session spending in real time. It really helps you avoid those terrible surprise invoices later.
It is an absolute lifesaver for independent developers. But the most powerful command by far is /plan.
/plan. Let's dig into how that one actually works.
It puts the AI into a highly dedicated planning mode.
Okay.
This is strictly a read-only phase. The AI deeply analyzes your entire code base.
Right.
It maps out all the structural dependencies first. It does all this before it executes a single line of code.
I have to push back a little bit here.
Sure.
Doesn't using /plan slow you down if you just want a quick, easy fix?
I hear that constantly. It does feel slower for about 30 seconds.
Right.
But you have to think about the alternative. Say you rush a quick fix without planning.
Okay.
The AI hallucinates a downstream dependency. It modifies a core module and breaks your entire build.
Oh, man.
Now you spend 2 miserable hours debugging a completely avoidable error.
Upfront planning maps the blast radius, preventing massive downstream debugging headaches.
That is exactly right.
Nice.
It keeps your underlying architecture totally stable.
Planning is definitely essential, but an AI's plan is only as good as its understanding. It needs to know your specific project rules. Which brings us to the actual setup file.
Ah, yes. The CLAUDE.md file.
Yeah.
This is basically your automated AI onboarding document.
It is a persistent instruction file, right?
Exactly.
The system reads it at the start of every single session.
Right. It ensures baseline consistency across your whole team. You don't have to explain your tech stack over and over. It already knows you use React and Tailwind.
But the leak revealed a critical mistake developers are making here.
A huge mistake. And it all comes down to the length of that specific file.
Okay.
The leaked code referenced a fascinating internal research paper. It was marked as ArcCiv 26.0.2.11.988.
What did that paper actually prove mechanically?
It proved that context files over 300 lines actually degrade the AI's performance.
Wait, seriously? More instructions actually make it perform worse?
Yes, because of how the underlying transformer attention mechanism works.
Okay.
When you overload the context window with hundreds of rules, the AI's attention gets heavily diluted.
Right.
It starts hyperfixating on obscure formatting rules at the bottom. Meanwhile, it completely forgets your core architectural guidelines at the top.
I have to admit, I still wrestle with prompt drift myself.
We all do.
I always want to dump a whole textbook of rules into the system.
It is a totally natural human impulse.
Yeah.
We naturally assume that more instruction means better results.
Right.
We want to cover absolutely every possible edge case, but the model just loses its core focus. The golden rule from the leak is strict. You must keep this file under 200 lines.
So it needs to be incredibly concise.
Yes.
What exactly goes into those 200 lines?
It should be highly opinionated. It should focus exclusively on operational gotchas.
Okay.
Things that would normally trick up a brand new human hire.
Like specifying the exact testing framework you were using?
Right.
Or outlining strict code review standards?
Yes. Or defining very specific database migration rules. You explicitly tell it to never modify schema files directly. You instruct it to always ask before making destructive environment changes.
Right.
You keep it brutally short. You keep it purely operational.
If space is that tight, how do you ruthlessly decide what makes the cut?
You strictly exclude anything the model already knows.
Give me an example of that.
Well, it already knows how TypeScript works natively.
Right.
Read the entire internet. It doesn't need a basic syntax tutorial.
Makes sense.
It only needs to know your specific team quirks. Does your team require unit tests right next to the source files?
Yeah, a lot of modern teams do that.
Then that specific rule goes into the document. Everything else gets cut immediately.
Only include unique team rules and completely cut general programming knowledge.
That is the secret. It keeps the agent incredibly sharp.
Okay, so you have the perfect 200-line onboarding document.
Right.
But there is still another major bottleneck we need to discuss.
How's that?
Because a junior developer is entirely useless if they have to ask your permission to use their keyboard.
Oh, man. This is where most workflows just grind to an absolute halt.
Yeah.
People are hamstringing the agent completely.
We were talking about the settings.json permissions.
Yes.
The leak showed they are bottlenecking users everywhere. If Claude asks for permission for every single git status check, you lose about 40% of your speed.
It completely destroys your flow state. You tab over to the terminal, you hit yes, you go back to your code.
It is exhausting.
It really is.
Yeah.
By default, the system plays things incredibly safe. It asks for explicit approval on almost everything it does.
But the leak showed us how to properly configure this, right?
Yeah.
Let's talk about the allow, ask, and deny arrays.
Right. It operates on a strict permission hierarchy. The deny array is the absolute top level.
Okay.
It overrides everything else.
So if something is in the deny array, it is totally off limits.
Exactly. If you deny access to your production environment variables, the AI absolutely cannot touch them.
Right.
Period. End of story. Next is the ask array.
Okay.
This explicitly pauses the AI's execution. It waits patiently for your manual human approval.
And then there is the allow array.
Yes. The allow array lets the AI perform actions entirely automatically. No human approval is needed at all. It just runs the command and reads the output immediately.
I have to ask, though.
Sure.
Isn't whitelisting commands in the allow array basically giving the AI the keys to the kingdom?
It definitely is. If you whitelist the wrong things.
Right.
You never whitelist a database drop command. That would be insane.
Obviously.
But whitelisting basic read-only commands is entirely safe.
What kind of read commands are we talking about?
You allow it to run git status. You allow it to read your basic source files.
Okay.
You allow it to run your local test suite. These actions cannot destroy anything.
And you combine this with breaking the actual work into distinct stages.
Yes. The optimal flow is search, plan, implement, and verify. You completely stop using giant monolithic text prompts. You let the AI search your code base autonomously. It builds a map, it plans the necessary changes, and then it explicitly asks your permission to implement them.
So how do you find the exact line between safety and maximum speed?
You heavily automate the information gathering phase,
Okay.
but you strictly gatekeep the actual execution phase. You let the AI read files and run tests without ever asking you.
Right.
But you force it to pause and ask before writing or deleting anything. That specific setup gives you maximum velocity with total structural safety.
Whitelist harmless read commands, but always gatekeep the destructive write actions.
That is the perfect operational balance. Sponsor break.
Sponsor. Okay, let's unpack this next part.
Let's do it.
Because this is where the implications get massive.
Yeah.
Once your permissions actually allow the AI to move quickly, where does it go next?
Right.
It goes straight outside the code base.
This is where things start getting really expansive. The AI connects to your broader technical environment through MCP.
MCP, let me define that really quickly.
Go for it.
A standardized protocol securely connecting AI to your local development tools.
Exactly. MCP is an absolute game changer.
Sure.
It basically connects the AI directly to your local databases. It securely links out to your internal company APIs.
Right.
It even talks directly to your external documentation systems. It essentially turns the AI into a deeply connected, smart workbench.
It stops being just a smart keyboard.
Right. It becomes an active operator. You can spin up a specific Docker test pipeline. It can query a live staging database to check for bugs.
Wow.
It becomes a central command hub for your entire engineering ecosystem.
That is wild.
But the NPM leak showed us something even more profound hiding in the architecture.
You are talking about the hidden capability flags.
Yes. The leaked source code contained configuration flags for massive features.
Okay.
Features that aren't publicly available to developers yet. They are actively building native voice mode capabilities. They are developing complex, coordinator-style multi-agent systems.
And then there is the background agent,
Yeah.
the one they internally codenamed Kairos.
Kairos is completely fascinating. It is a purely proactive background agent.
Okay.
It quietly monitors your daily developer logs. It watches your terminal event streams in real time.
Mm-hmm.
It basically operates completely invisibly in the background.
Whoa. Beat. Imagine a proactive AI running in the background, summarizing your work and managing schedules while you are entirely idle.
It is a wild concept, right?
Yeah.
Think about the practical workflow.
Okay.
You step away from your desk for an hour to grab lunch. Kairos quietly notices a failed test in your continuous integration pipeline.
Oh, wow.
It autonomously investigates the error logs. It writes a highly detailed proposed code fix.
Right.
And it just has that fix waiting for your review when you finally sit back down.
That is incredible. But does Kairos cross the line from a helpful assistant to an autonomous worker?
It definitely blurs that boundary. It moves completely away from waiting for your explicit text commands.
Mm-hmm.
It starts anticipating your actual engineering needs. It actively watches the local environment.
Right.
It decides when to intervene based on deep contextual clues.
Yeah.
It basically becomes a persistent virtual coworker rather than a simple reactive tool.
It shifts from a reactive text assistant to an anticipating autonomous coworker.
That is exactly what is happening under the hood.
Mm-hmm.
And this actually brings everything together into the core philosophical takeaway of this entire leak.
We are talking about the defining shift in the industry right now, the concept of agentic persistence.
Agentic persistence.
Yeah.
It basically means the AI is no longer just passively listening to your text prompts.
Right.
It is actively building a complex real-time graph of your repository state.
Mm-hmm.
It deeply maps your Git history. It understands the nuances of your local environment.
Wow.
And crucially, that understanding persists across multiple coding sessions.
So top-performing developers don't just write better text prompts anymore. They build better operating environments.
Like, that is the absolute biggest takeaway here. You have to stop prompting harder.
Right.
You need to start setting up better. If you are constantly struggling with the AI, your prompt is probably not the issue.
Mm-hmm.
Your underlying environment configuration is the issue.
You need to keep your setup file incredibly sharp.
Exactly.
You need to actively use those hidden / commands. And you absolutely need to configure your JSON permissions correctly.
You do those three things and the entire tool transforms.
Mm-hmm.
It completely stops feeling like a fun little novelty. It starts feeling like an integral structural part of your engineering workflow.
Right.
The power is already built natively into the tool. You just have to unlock it properly.
Which brings us to our call to action for you, the listener.
Yes.
You really need to audit your own workflows today.
Definitely.
Look closely at your claude..md file. Count the lines. If it is over 200 lines, you need to ruthlessly trim the fat.
And critically, check your settings.json file. Audit those specific permission arrays.
Right.
Stop approving every single basic read command manually.
It really is time to let the agent actually run.
It is.
But unpacking all of this leaves me with a final thought I can't quite shake.
What is that?
If tools like Claude Code are already building real-time graphs of your repository state, and they already map your entire Git history,
Right.
what happens to the role of the human developer when the agent transitions?
Yeah.
I mean, when it stops just understanding the basic syntax of the code and starts understanding the actual business logic and human psychology behind why the software is being built in the first place?
2-sec silence. That right there is the real frontier.
Thanks for joining us on this deep dive. We will catch you next time. Outro music.